Welcome to this session number 9 from the playlist of alternating current. The topic for this session is the power dissipation in a LCR circuit, and today I have taken one question which was asked in the IIT-JEE examination in the year 2010. So in this question we have been given that the resistance of a resistor is 200 ohms. The voltage and the frequency of the supply is 220 volts and 50 hertz respectively. On taking out the capacitor from the circuit, the current lags the voltage by 30 degrees, and on taking out the inductor from the circuit, the current leads the voltage by 30 degrees. So we have to find the power dissipation in the LCR circuit. So the power dissipation in an LCR circuit is given by V I cos phi, where phi is the phase angle between the applied voltage and the current in the circuit. Now we also know that tan phi is equal to XL minus XC upon R, where XL is the inductive reactance of the inductor, XC is the capacitive reactance of the capacitor, and R is the resistance of the resistor in the circuit. So on taking out the capacitor, the current is lagging the voltage by 30 degrees. So here phi will be equal to 30 degrees. So tan phi will be equal to tan 30, and this will be equal to, since we have removed the capacitor, so this equation will be equal to XL upon R. Or simply we can say that XL will be equal to R upon root 3. So the value of this inductive reactance is equal to R upon root 3. Now, while taking out the inductor from the circuit, the current is leading the voltage by 30 degrees. So tan 30 here will be equal to now XC upon R, or it implies that XC will be equal to R upon root 3. So the capacitive reactance is equal to R upon root 3. Now we know that when XL is equal to XC, then the LCR circuit becomes a resonant circuit. Now here XL is equal to XC. You can see here XL is equal to R upon root 3 and XC is also equal to R upon root 3. So here the phi, that is the phase angle between the applied voltage and the current in the circuit, is equal to 0 degree, because in the resonant circuit the phase angle between the applied voltage and the current which is flowing in the LCR circuit is equal to 0. So power dissipated in the LCR circuit will be equal to VI, because cos 0 is equal to 1, and this equation can be written as V square by R, which is equal to 220 whole square divided by 200, or this can be written as 220 into 220 upon 200. So this will get cancelled out, and finally I am getting the value of the power dissipation in this LCR circuit as equal to 22 into 11, and this is equal to 22 into 11 is equal to 242 watts. So the power which is dissipated in this LCR circuit is equal to 242 watts. Sorry, it is 242 watts, and the correct option is A, that is 242 watts. Now in this question, the most important thing was that first of all we were supposed to find the value of XL and XC, and because in this question, since XL is equal to XC, so it becomes this resonant circuit. And in the case of a resonant circuit, the phi, that is the phase angle between the applied voltage and the current in the circuit, is equal to 0. And so we will be simply putting the value of phi as 0. So we will be getting P is equal to Vi, which is equal to V square by R. And so the final answer is equal to, that is the power dissipated in the LCR circuit is equal to 242 watts. And the correct option is A. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question. And so till then, have a nice day. Bye.